Right, next up, we have got some stats. So this is a cumulative frequency graph, shows the distribution of heights of members of a rowing club. The very first question right down at the bottom, find the median. That's the middle person. So we are going to go to our cumulative frequency scale, which goes all the way up to 120. And we're going to halve that, 60. We're going to draw a line across from 60 till we get to our curve, and then very carefully we're going to go horizontally down, vertically down. So this is our median, which comes out at 172. You can just see down there. Now, we're going to need our graph again because the next section says find the interquartile range, and the interquartile range is the upper quartile minus the lower quartile. So we are going to have to find our quartiles. The upper quartile is halfway between the median and the maximum. So in this case, we're going to find 90 on our cumulative frequency scale. Again, same as we did with the median, go across to the curve and then straight down. And I get that being 177. Our lower quartile, our lower quartile is halfway between the median and the minimum. So that's going to be at 30. Which means that's come out at 160. Oops. LQ, not 4Q. Right, so if we go back here, we had an upper quartile of 177, take away a lower quartile of 160, that means my interquartile range is going to be 17. And then it says, calculate the percentage of members who are at least 180 centimetres tall. Back to our graph again. We're going to find 180 on our height scale. We're going to draw a line vertically up to the curve. And then where it gets to the curve, we're going to draw a line horizontally across. And it gets to 100. That means that there are 100 people up to the height of 180 centimetres. We want the people who are at least 180 centimetres. So we're going to do the total number of people, take away the number of people who are up to 180 centimetres. That means that there are 20 people who are at least 180 centimetres tall. We've got to turn that into a percentage. At the moment, it's 20 out of 120. If we can turn that into a fraction out of 100, that would be the easiest way. So divide by 120 and times by 100, or whatever you want, will give you 16.6 reoccurring, which is our percentage. Now, this graph is a little tricky to see. I think it's been photocopied one too many times. If I just go over the key lines, hopefully you'll make them a little more obvious. We've got a histogram. Now, what we need to remember about histogram is that frequency is shown by the area it takes up. So frequency is the area of each bar. To work out the frequency, we do frequency density times by the class width. So frequency density class width. We've got to find out which club has the greater median height. The rowing club, which we were just looking at, they had a median of 172, or the swimming club. So what we've got to do is find out, of our 153 members, who is the median person. The median member is going to be the 153 plus 1, all divided by 2, the 77th person. Okay. So we are going to start at one end or the other. I'm going to start at this end, and we're going to work out how many people are in this group, how many people are in the next group, and we're going to keep on going until we have gone past the 77th person, because that means that we've found the group that the 77th person will be in. So first of all, for 140 to 160, our class width is 20 and our frequency density is 1.4. So we've got 1.4 times 20, which gives us 28 people. If we go for the next group, that's for people in the height 160 to 170. That's got a frequency density of 7.4 and a class width of 10, so that means there are 74 people. That means if we add these two together, we have reached our 102nd person. That must mean that the 77th person is in this group here. So the rowing club has a higher median. Just a second. The largest, so the highest the median of a swimmer could be is 170 centimetres, because they must be in the group that goes from 160 to 170. Okay, this graph shows the speed of a train during the first 60 seconds of motion. What is the speed of the train after 9 seconds? 5, 6, 7, 8, yes, that's going to be 9. So line up to the graph, up to the line of the graph, and then across to our y-axis. That's 12 meters per second. What does the straight line suggest about the speed of the train over the first 15 seconds? It's accelerating at a constant rate. Okay, now for the fun bit. Work out the average speed of the train in meters per second during the 60 seconds. Speed equals distance over time. We know that our time is 60 seconds. We need the distance. The distance is the area underneath this graph. Now, we can find that by cutting it up into two triangles and a rectangle and adding the areas together, or we can use the fact that it is a trapezium, and we can use our formula for the area of a trapezium, which is half A plus B, which is our two parallel sides. So in that case, we've got the top one being 35, 50 take away 15 is 35, and the bottom one being 60. And then we're going to times that by perpendicular height, which is the maximum speed 20. If we plonk that into our calculator, it comes out at 950 meters. That is the distance that the train has covered. Okay. The time we know is 60 seconds. So speed equals 950 divided by 60, which is 15.83, and the 3 recurs. That is their average speed over the whole time. Okay, next up we have got some vectors. This diagram shows triangle OAB and points C and D. OA is 3A, OB is 3B, that's been marked on for us already. D is such that BD, this line I'm about to draw in, is 2A plus B. Show using vectors that OCD is a straight line. So to prove this is a straight line, we need to prove that OC and OD have vectors that are one's a multiple of the other. And this means if one's a vector multiple of the other, that the two lines are parallel, and because they both have point O, they must therefore be the same line. Okay, so here's what we're going to do. Oh, and we missed a bit. Line C lies on AB such that AC is 2CB, so this is 2, if it's in a ratio 2 to 1. Now, what we're going to do is we're going to have to get from O to C. We're going to need that vector. But before we can do that, we are going to have to get from B to C. But before we can do that, we are going to have to get from B to A, because we can do that. B to A is minus 3B plus 3A. Now, B to C is 1/3 of that distance because the line has been split in a ratio 2 to 1. B to C equals minus B plus A. And then we want to go from O to C, so we're going to go 3B minus B plus A. Oops, sorry, OC, sorry. Now we're going to have to work out how to get from O to D. This is fine, we can trace a route for that straight away. It's 3B plus 2A plus B. So that's 4B plus 2A. And we can factorise that. It's 2 lots of 2B plus A. Now, because we can factorise that, and one of the factors is the same, that means that OC and, the line OC and the line OD are parallel because OD is a multiple of OC. They're the same line because O lies on both. Oops. Okay.